Okay, so we are going to do a free response type questions on combining random variables. And actually, we're going to have expected values transforming and combining random variables, all of them mixed together. So our scenario is a small business just leased a new computer and color laser printer for 3 years. The service contract for the computer offers unlimited repairs for a fee of $100 plus a $25 service charge for each repair needed. So this is a service contract for the computer, and basically they're saying the computer equals $100 a year plus a $25 for each repair. $100 plus 25 per repair. I'm going to put a Y here for year. All right. The company's research suggested that during a given year, 86% of these computers needed no repairs. 9% needed to be repaired once, 4% twice, and 1% 3 times, and none required more than 3 repairs. So basically, we can have 0 repairs, 1 repair, 2 repairs, or a total of 3 repairs. All right. It says 86% of them don't need repairing ever. All right. 9% needed to be repaired once, so 0.09. 4% twice. And 1% needed to be repaired 3 times. They said none of them need to be more than 3. So let's check this out real quickly to make sure that we have a valid probability distribution. And remember, to be a valid probability distribution, this has to sum up to 1 whole. So we have 0.86 plus 0.09 plus 0.04 plus 0.01. Sure enough, we have 1 whole. So this is a valid probability distribution because none of the values are negative, none of the values are greater than 1, and each probability sum together to equal 1. So it says find the expected number of repairs for this kind of computer needed in an expected year. Well, remember our expected value formula, and we need to be writing that down, and that can be either expected value or the mu sub x equals the x sub i's times the p sub i's. So your individual x's times your individual probabilities. So showing my work, it's going to look something like this. The expected value equals 0 times 0.86 plus 1 times 0.09 plus 2 times 0.04 plus 3 times 0.01. All right. Now I went ahead and I stuck that into stat edit. So stat edit. And there's my values, 0, 1, 2, and 3. And here's my probabilities. So stat calc, 1 variable statistics. My X list is an L1, so second 1. And I do have a frequency, so I need to turn my freq on, which is going to be L2, second 2. And I end up getting an expected value of equal to 0.2. So this is the type of sentence that you need to write for that problem, which says, on average, we expect each computer to need 0.2 repairs per year. And it's really quick, really important that you have this on average, and then we expect each computer need 0.2 repairs per year. The next thing says, find the standard deviation of the number of repairs we need. All right, so we're going to need our standard deviation formula. And our standard deviation formula is basically the standard deviation equals summation. And I should have had a summation sign here, by the way. Summation of the x sub i's minus mu squared times the associated probability. In other words, each individual x minus the mean times the probability. We already said the mu, or the expected value, equals 0.2. So we have that value. So I just need to go back up and plug in. So I basically have, use a red pen. I basically have my first x was 0. So 0 minus 0.2 squared times the associated probability, which is 0.86, plus 1 minus 0.2 squared times the associated probability of 0.9, plus 2 minus the associated probability of 0.2 squared times the 0.04, plus 3 minus 0.2 squared times the associated probability of 0.01. And I need to take the radical, put that all underneath the radical. And that gives me a standard deviation equal to 0.5477, right? Standard deviation is equal to 0.5477. And that's really all you need to have for that. So once again, the individual x minus the mean squared times the associated probability. Individual x minus the mean squared times the probability, et cetera, all the way down. And of course, if you wanted to abbreviate, you can use the first and last bookend. So it says, what are the mean and standard deviation of the company's annual expenses for the contract? Well, first off, we had to go back to our original equation, and we said basically we expect the expenses to be $100 a year plus $25 a repair. All right, $100 a year plus $25 a repair. So our equation basically is y equals 100 plus 25x, where x is the number of repairs. Well, what do we expect? Well, our mean is just going to be, hey, we're just going to plug directly into that equation. So it's going to be 100 plus 25 times, how many repairs do we expect? We expect 0.2 repairs. All right, so our mean is basically going to be about $105. And basically, this is where we're going to come back and we're going to put this in context. And it's going to say, on average, we expect to spend $105 a year for repairs. All right, on average, we're going to expect to spend $105 a year for repairs. So that's our sentence. Once again, these are the key words: on average, and we expect. On average, we expect. But we haven't done the standard deviation. So I'm going to go back and use the same formula, which is 100 plus 25x, and I'm going to plug in. But now we're looking for the standard deviation. All right. So the standard deviation, all right, is 100 plus 25 times the 0.5477. This is where things get a little bit crazy. We have to be a little bit careful on this. Remember, we cannot add constants to measures of spread. So this $100 goes away. We cannot add a constant to the measures of spread, but we can multiply by a constant. So here we are using our transforming rules. So when I do this, essentially I'm just going 25 times the 0.5477. And I end up getting $13.69. So my standard deviation equals 13.69. So I need to contrast these two. So here with means, I can add a constant and I can multiply by a constant, and it just changes by those values. It changes by the value added and it changes by the value multiplied. With standard deviation, because it's a measure of spread, we can't add a constant, but we can multiply directly. All right, the next question. How many times should the company expect to have to get a computer repaired over the 3-year term of the lease? Well, that's a good question. So when we come back to that, we're basically going, all right, How many times do we expect to get in the first year? And then the second year? And then the third year? Well, we don't have any information that indicates things changes, and we expect it to have to get repaired 0.2. Well, I can add means directly. I can add measures of center directly. So this is when I'm combining my random variable, and I can go ahead and combine them together with means just by adding them up directly, and I don't have to do anything fancy. There's no restriction. So this is going to equal 0.6, all right? And so our sentence is going to be, once again, key phrase, got to get this down. On average, we would expect a computer to need to be repaired 0.6 times over the 3-year time frame, all right, or over the 3-year lease. But on average, we would expect are the phrases that you really need to focus on. The next is, what is the standard deviation of the number of repairs that we may be required during the 3-year lease period? All right. Well, with standard deviation, still we're looking at going, you know what, we have x1 plus x2 plus x3. So I'm going to sit there and go, all right, what was my standard deviation? So plugging in, I have 0.5477 plus 0.5477 plus 0.5477. But remember, we cannot sum standard deviations directly. We have to convert them to variances, and all we need to do is square them. And since we want it as a standard deviation, I'm going to have to come back, and after I sum them, I'm going to have to take the square root of them. So those are going to be my values, all right? All right, so that's going to be my value, and when I do that, I should go, let's try this out, 0.5477, and I'm going to square it, enter, and I'm just going to multiply that by 3 because that's 1, 2, 3 of them, times 3, and I'm going to take the square root of that. And I end up getting 0.9486. So my standard deviation for this equals 0.9486. But there's another part of this question. On what assumption does the calculation rest? Here, I don't have an assumption. I just get to do it. For means, it's no big deal. I can combine random variables for mean, not an issue. But here I have an assumption. And the assumption is that each year is independent. That each year's repairs are independent. Now, is that a reasonable assumption? And the answer is probably not, because generally speaking, things that break tend to break more frequently. So once they start breaking, they begin to break. Also, it could be due to the fact that for me, my computer skills not great. So consequently, I tend to cause things to break on computers. And so it may be related to the machine being faulty or the individual operating it having problems. The assumption rests on the fact that repairs are independent from year to year. Remember, to combine standard deviations, it has to be independent. I doubt that this is reasonable, as things that break once tend to break more readily than things that haven't broken. And the failures may be related to the care and skill of the computer operator or to a poorly designed computer. All right. So you need to make some sort of addressing. So technically, we probably shouldn't have done that, but they gave it to us, so we did it, and then we said this was the assumption, and then we moved on. The service contract for the printer estimates a mean annual cost of $120 with a standard deviation of 30. What is the expected value and standard deviation of the total annual cost for the service contracts for the computer and printer? Okay, so we need to sit there and think about things. All right, so and they're asking for what is the mean annual cost. So we need to calculate that out. Well, what was the mean annual cost for the computer? Well, up here, we said that the computer had a mean annual cost of $105. And here they're telling me it has a cost of 120. Well, I can add these two together and I get 105 plus 120 equals 225. All right. So this would be my expected cost. And basically, if I wanted to use a symbol, I could say the mean of the computer plus printer equals the 105 plus 120. So the mean of the computer plus printer equals $225. And what that really means is on average, we'd expect to pay $225 total for the printer and computer costs. Okay. All right, the standard deviation. Well, what was our original standard deviation? Our original standard deviation for the computer was $13.69. So we can say this is standard deviation for the computer is 13.69. And now we want to add the printer. Well, they tell me the printer had a standard deviation of 30. So I come back and I go, all right, I want to add the computer and printer. So I'm looking for the standard deviation of the computer plus printer. So I put 13.69 plus 30, but remember, I cannot combine measures of spread directly. I have to convert them to variances and take the square root of. When I do that, I end up getting the combined cost being $32.98. Okay. All right. Finally, it says, which service contract should the company expect to pay more? Well, they're going to say, all right, that means you're going to subtract them and say which one you expect to pay more and with what standard deviation. Well, for means, basically they're saying we're going to have the mean of the computer or mean of the printer minus the mean of the computer. And I can subtract directly, and it's like, okay, the printer is $120 and $105. So we expect to pay $15 more for the computer, and we subtract directly. But with standard deviations, when they ask for the standard deviation of the printer minus the computer, I can't subtract them directly. I can only add them, and so I combine them as a variance, and I end up with 13.69 plus 30 squared. Because once again, they're saying this is what we want you to do, but we can't subtract them. We have to add them, and we can only work with them as variances. So we have to square them, and then we take the square root of them. All right. Now, that is combining random variables and a mixture of expected values combining and transforming. Remember, to combine random variables, you can add means directly. You can subtract means directly. There's no limitation. To do standard deviations, you're going to have to convert it to a variance. They're going to have to be independent of each other. And these two probably are independent. All right, these two probably are independent. The computer is probably reasonably independent of the printer. So we probably could have done that. So that's probably a good assumption. And remember, we're going to have to square up, convert it to a variance, sum them, and then take the square root of them. You cannot subtract them. All right. When it comes to transforming, when you multiply, you can multiply everything by a constant, and it all changes by the multiple, with the exception of the variance, and that changes by the constant squared. All right. When you're adding constants, you add constants to measures of center. In other words, your mean and your median, but you cannot add constants to measures of spread. If you have some confusion on this, I highly recommend you to watch the previous video. Go back and watch the previous video as we break down a lot of those problems. All right, thank you.